Your voices are also recorded, unfortunately. Okay, so do you have any question from the previous lecture other than zero force members?
No.
No?
Yes. When I'm solving, some of the members, like, I get a definite zero, but all the time, like, I get some suspicions. Will it be other than zero if I took it like from another joint?
For example, here I will give you one answer which will help you for solving the questions. If the forces are bigger, like you are solving a truss having a bigger forces like 100 kilonewton, 200 kilonewton, okay, and your answer is like 0.1 or 0.5, even up to 0.9, I think you can consider that member as a zero force member. But if your forces are very small, like 1 kilonewton, 0.5 kilonewton, like that, or even 2 kilonewton, and you are getting answers like 0.1 or 0.5, then I think it should not be considered as a zero force member. Okay? So let's talk about, if you can just turn on the printer. You are a good guy, I know.
Agora.
So,
Deixa.
zero force members. You know, I mean, sometimes if you got a question in your exam that what are the zero force members, so one of the worst ways that to solve that truss. Okay, that is one of the worst ways. If you have plenty of time, take this opportunity and solve the truss, and you can find out which force, which members have zero forces. Okay, that is the one way. Another way is that, which is we are going to discuss right now. We can judge, we can decide that what members or which members will be the zero force members. For example, in this truss, if you look at joint A, is there any other force on joint A? Look at joint A and C.
Just the members.
I think we have to turn, it's better if we turn off the light, you are right. So just have a look at joint A and C.
The two members at
I mean,
we
okay,
have some
at
reactions.
joint A, do you have any other force at joint A?
No.
Okay, so apply sigma Fx. Or apply sigma Fy. Sigma Fx and sigma, according to the method of joints, apply sigma Fy. So there will be only one force, and that will be 0.
But we have other forces and we answer.
Whatever. But if you start solving from the method of joints and you solve joint A, so if you solve joint A, you will be having zero force in these two members. The same thing is about joint C. So can you judge? What about E?
No, we have four.
You know, the force in member BE, it's very easy to find the force in member BE. That will be equal to the reaction at point E. Do you understand?
Yes.
Even without solving the truss, you can tell how much will be the force. The exact force, which is here, is not going to any member, left or right. It's directly going out. So if the force in this member is 0, so the force in this member will also be 0.
Yes.
0. And the force in this member will be 0. So there will be only two members which could be stressed. Well, I'm not going in more debate because I want to keep your life simple. Now, the same thing, let's talk about this truss. In this truss we have three members but no external force at joint D. I think if I just make this force P exactly like this, it will become the same situation, this one. If I put a force, just try to understand, so, which I explained. For example, if I just shift this force like this, so this force will directly go to this member. And these two forces will be equal. Without any analysis you can tell. But what about joint D? The same thing about joint D, there are three members. So, and if you just rotate this joint D, it will become similar to joint E without support. If you understand, it's good. But if you do not understand, use the method of joint and solve it.
This means we have to choose the first member, PG and DFD.
No.
In this case, you could be having three zero force members. You could be having, okay? But I think this member DE, it will not be a zero force member because of this reaction. You know, there is one reaction. There will be one reaction here. So because of this reaction, there will be some force going to this member. Okay? And this member also. But what about this member? This member will be zero force member. The force in this member will be equal to this member, but the force in this member will be zero. Because if there is no force like this, it should be zero.
What about CF?
CF, it will not be zero. Why?
Because it has an angle.
Because there are four members. There's the first thing. The other thing, you know, there will be a vertical reaction. So this force will not be zero.
Yes.
So it means if this force is not zero,
Extension of that.
so the horizontal component of this force will be equal to this force.
Yes.
Do you understand? So if this force is not zero, this force will also not be zero.
And the horizontal components of
Because that is the sum of the horizontal components. So of course there will be some value of these forces. So I can tell that these forces will not be the zero force members. Okay? This truss. In this truss, if you see joint, again, the situation is very similar. At this joint, no force other than this. Only three members. No force here, no force here. Apply sigma Fy. It will be zero force or not zero force? No, it will not be zero force. There will be some force. The force in this member will be equal to this. And you cannot solve in the x direction because in the x, these two forces will be equal. But how much are the forces? We don't know. But what about this member?
there will be equal to the horizontal component.
There will be a reaction here. I think it's a roller. There will be a reaction here.
And A, there will be two reactions.
Yeah, teacher. A would have two reactions.
So there is no zero force.
So, and what about HB?
HB is zero.
No.
HB is zero.
How many of you say HB zero? If HB is, if member HB is perpendicular, if I'm not sure it's perpendicular or not.
No.
I'm not sure. If it is perpendicular, it should be zero. Okay? If this member, if this angle, I'm not sure it is 90 or not, because no dimensions are given here. Okay?
Maybe CF.
But C,
CF.
again, I don't think so it's perpendicular.
No, it's not the C.
Well, this is how you can identify which member is a zero force member. There is a certain rule. The rule is very simple. The first rule, if there are two members joining together and there is no external force, like here, like at joint A and C, if there are two members joining together and there is no external force, it is 0. The force in these two members will be 0. If there is no external force and there are only 2 members. But if there are 3 members, like here, like at joint D, there are 3 members, so the perpendicular one will be 0. Okay? And for this truss, you have to check. For this truss, you have to check.
For this truss, this DN, EF, actually GN, all of them are 0 force members.
See what I'm saying? I'm not sure about the exact angle. The angle, for example, in this case, HB, H, from here it seems not, from here I cannot see it's perpendicular, but from my slide I can see it is perpendicular. From the slide, or if you see the book, yeah, if you have the book, in the book you can see it's perpendicular.
Yes.
Can you see?
Yes.
But still, they are solving the whole truss. I'm not sure. In the book, it seems perpendicular.
Yes.
Yes. And this, of course, if there were 2 members, no external force, they will be 0. I just told you some time before that if there are 2 members, no external force, these 2 members will be 0 force members. Like
CD and E.
like joint A and joint C. Okay. Well, your book has solved this. Well, it's good. They have time, but you can decide and you can tell. But in order to decide, you have to be a little bit intelligent and expert in solving the process. Can you wake up this guy? So what are you doing? Are you in the class? Be here, otherwise you will miss something. Method of joints. Can you solve this truss by the method of joints?
Yes.
It's very easy.
You do moment.
First find out the reactions and then solve joint A. The horizontal reaction at joint A will be equal to 500
Yeah.
and the vertical reaction will also be equal to 500. 500.
Yeah, if we do the moment
Because
at C.
moment.
Yeah.
Moment at C, it would be.
It will be 500. 500.
Yeah, same distance, 2 meter, 2 meters.
So it is like this because you have to balance. If you see this 500 Newton is producing a clockwise moment.
Okay, yeah.
So in order to balance it, you need a counter moment from the support, and that will be again 500 into 2 because all these dimensions are equal. So the moment will be this is upward and this is downward. So if now you have 2 forces here, the force in member AB will be equal to 500.
Yes.
The force in member AC will be equal to
500.
500. Without solving with the method of joints, you can find the forces. Okay? So only this joint is left. You can solve this joint. Okay, so the next is method of joints. I give you want me to solve this truss by the method of joints? I will do one example because of time, either with the method of joints or with the method of sections. So it's your choice what you want me to do. Method of joints,
I would say sections.
method of sections? Okay. So method of sections, it's tricky. I will not say easy because if you have to, for example, if you have to determine a force in member GC or GF or BC, so you can take a vertical section. What is the method of section? For example, if you have to find out the force in member FD, So you should take a section passing through CD.
Yeah.
So if you solve this, you can find the forces in 1, 2 and 3.
Yeah.
Your section can pass maybe 4 members, 5 members, but if there are 3, it's very easier to solve. Okay? You can also take a section like this. For example, you can take a vertical section like this, you can go this way, and you can come down. And then you can isolate that part from the other part, and you solve any part, right or left, you can find the forces. But I think now I give you the choice. You can tell me the truss or example or problem, whatever you want me to do here. I don't want to stick particular to this problem, which is the example. If you want me to solve any of the problem, you're welcome. Of your book. For example, what examples I have here? This one, and this one.
3.7.
3.7. So, you want me to solve 3.7 or 3.8 or 3.6?
Nice day.
Yeah, no.
Okay, let's solve 3.6. 3.7 is easier than this. Because in this case, 3.7, you know, this is joint B. If you read the question, what is the question?
Determine the force on the members BC, MC, and of the K-truss shown in the figure. State with the members are contention or compression. The
If you
reaction.
see, it's comparatively easier to find out the force in member BC. Okay? But this truss, because of geometry, I think we should solve this problem. Or if you want to have any other problem, I can draw it for you. Is it fine? Or 3.7? Okay, if you want 3.7,
I think it's easier. 3.7.
3.7 is easier. It's my thinking. Maybe you can find it difficult, but I think 3.7 is easier. And 3.8 is even more easier. It is similar. I mean, if you know the way, whatever is the truss, you can solve it. That's the bottom line. If you know the way, whatever is the shape of truss, you can solve it. Okay, so let's solve this truss. I'm going to draw this truss in a new slide. And let's solve it. So, if you want me to change the values, can I have your book? Okay. This is member, and then I have one member here. And then no vertical number is and it is 3 meter. and the height is 4.5 meters. The total height is 4.3
and 4 yeah.
meters.
And 1
1 point.
Here we have and then we have forces 6, 8, 2. Here we have 6, 8, 2 kilonewton.
Yes.
Yes. And 6. Okay. And then A, B, C, D, E. This is A, B, C, D, E, F at the top. Yeah, F, E, G, H. So, and we have to find the force in which member? G, F, and G, D.
Also the reactions.
A, Y.
Reaction.
Yes, so we have to find the reactions are given, okay. But maybe in your exam I will not give you. Why?
The summation of x and then moment t.
Is there any horizontal reaction? Zero. It is 0. How much is this? EY?
7.
And how much is this one?
9.
So we have to find the force in member G, D, CD and GF. Is it right? GF and GD. So we have to pass a section passing through these two members. We have to pass a section which should, we have to draw a section which should pass through these two members. Okay. So let's cut this way, and you can give it any name. Now you have two choices. The first choice, consider the left side, and the other choice, consider the right side.
Right.
So you want to consider which one?
Right side. Right side.
Okay. Yeah, it's better to consider the right choice. But even if you consider the left, your answer will be
Same.
100% same.
Just longer.
Okay. So let's draw the the right side. This is member I should keep an eye all the time. Okay, so we have one member GF and then FE. This is member yeah, it is correct. So this force is 7 kilonewton.
Upwards, yeah. Next to it, 2. Downwards.
This is 2 kilonewton.
Yes.
Okay, and this force is what? You can assume that all these forces are going away from the joint. You can assume that. You can assume that, for example, all these forces are away from the joint. So you can assume all these forces are the tensile forces, the tension forces. So this force you can give it name F,
GF.
FG or GF, F,
DG.
DG
DC.
and F
DC.
D.
DC.
Okay, next. You can also draw the joint G if you want. You can draw the joint G but with a dashed line. Don't show with the solid lines. Okay? So do you understand till now?
Yes.
Next we have to find out the forces, remember FG, FDG. But before we go to solve this truss, let's also decide the angles. How much is this angle? This is 3 meters, 3 meters, so it should be 45 degrees. And how much is this angle? 1.5 over 3, not 45. 1.5 over 3, period inverse. How much is that?
26. $26.56.
26 point.
56. 26.6.
Okay. So what we should do now?
We should take
Solution.
joint E.
This joint is joint E
Yeah,
and this joint is joint D.
yeah. Take joint E to know the member EF.
This is G.
Yes.
If you see, we can take the moment at joint D. And if you take the moment at joint D,
You can get FG.
we can get FFG. Because at joint D, this force, the moment due to this force will become 0. The moment due to this force will become 0. This force, this force, this force. So 1, 2, 3, 4, 5. All these 5 forces, moments will become 0. And only we will get moment due to this force and due to this force. So that's the best way.
FGX.
Let's take moment at joint
D.
sigma moment E is equal to 0. Okay, you can divide this force into 2 components if you want, or if you don't want, we know the components. For example, at joint D, this 7 kilonewton, it will produce clockwise moment or counterclockwise? It will produce, at joint D, it will produce, so we can take it positive, 7 into
D.
E.
Teacher, moment is D. MD, not E.
Yes. And FFG, so it has 2 components. The vertical component will become
Cosine.
0. The horizontal component, it will produce which way?
Will be
Counter. So FG cosine
26.6.